We live in a world that's filled with movement and speed is all around us. Indeed, we live in a universe where everything is constantly in motion, even though they may appear to be stationary. For example, while the Earth may appear to be or feel like it's stationary, it is actually orbiting the Sun at a speed of 67,000 miles per hour or 107,000 kilometers per hour. That literally is how fast we are currently in motion at this very moment. Hi, I'm Captain Roy and welcome to my channel where I make videos and answer questions about ships. So if you would like to know more, then stay tuned. Come on board with me. It is easy to measure speed between two reference points when the distance and the time travel between them is known. The formula is simply the distance divided by the time travel equals speed. But what if there was no reference points available and the distance was unknown? Then obviously the formula cannot be used to calculate speed. Such was the case that the early seafarers faced when they sailed the seas. Therefore, another method had to be devised in order to measure speed. The method used came to be known as the chip lock method. Basically, the materials used consisted simply of a rope with a chip lock at the end and a sand glass timer. Knots were tied on the rope with each knot tied at an equal known distance from the next knot. Let's call this known distance x, as different peoples use different units of distance. To measure the ship's speed, the lock was streamed from the stern of the ship by throwing the end of the rope with the wooden chip into the sea. As the ship moved, the rope was allowed to be paid out and each knot was counted until the sand glass timer timed out. If the number of knots counted was say 10, then the ship's speed was said to be 10 knots. And the distance travelled was thus 10 times x. Fast forward to the present time and we find that we are still using the term knots, but now it has taken on a completely new and different definition. Basically, knots represent the number of nautical miles that a ship travels in 1 hour. If a ship travels 10 nautical miles in 1 hour, then the speed is said to be 10 knots. But to fully appreciate this statement, we should first know what a nautical mile really is. Going by definition, a nautical mile is defined as 1 minute of arc on a meridian subtended from the center of curvature. In other words, it is an angular measurement of distance. This presents problems as the Earth is by default not a true sphere. By default, the Earth is what is called an oblate spheroid because it is slightly flattened at the poles and bulges at the equator. Because of this, the length of a nautical mile at the equator is thus shorter than a nautical mile near the poles, as they have differing center of curvatures. At the equator, the nautical mile has been calculated to be 1842.9 meters, and at the poles, it has been calculated to be 1861.7 meters. As the difference is not so significant, an intermediate figure of 1852 meters is the accepted distance used in marine navigation to represent 1 nautical mile. Now that we understand what a nautical mile is, let's see how speed is measured and used in navigation on board a ship. A navigator is usually primarily concerned with 2 types of speed: ground speed and speed through the water. Ground speed is the distance traveled over the ground in 1 hour, and speed through the water is the ship's speed relative to the movement of the water, also known as the current. For example, let's take a ship that's heading north in calm water and has a ground speed of 10 knots. In this case, ignoring hull friction, ground speed will equal speed through the water. If the ship then encounters an opposing current of 2 knots, its speed through the water will increase by 2 knots to become 12 knots, and its ground speed will decrease by 2 knots to become 8 knots. The opposite will occur if the ship encounters a following current. Speed through the water will instead be reduced by 2 knots, and ground speed will be increased by 2 knots. On modern-day ships, ground speed is usually available via GPS satellite systems, but it also can be obtained by the ship's speed log instrument. Speed through the water is usually measured by the ship's speed log instrument. If the vessel is coasting near land areas, radar position fixes can also be used to counter-check the ship's speed. Ground speed and speed through the water are both highly important information for the navigator in determining collision avoidance, ETA calculations, or when evaluating the performance of the ship. As such, the navigating officer of a ship should always be sure of his ship's speed and its accuracy by comparing instrument readings and position fixes so that the vessel travels safely at all times. Once again, we've come to the end of the video. I thank you very much for watching. Don't forget to hit that like button, subscribe, have a great day, and I see you on the next